Hey, you like symmetry, don't you? There's just something so beautiful and maybe even natural about it. Well, what if I told you that nature is not that symmetrical at all?
Our reality can be defined into three types of symmetries: charge, parity, and time.
Imagine looking in a mirror. Come here. In physics, a mirror like this can represent a line of symmetry. Charge, or C-symmetry, essentially states that two charges, or any charge, will function the same on this side and on that side of the mirror world. For example, opposites repel on both sides. A negative becomes a positive and a positive becomes a negative. Parity, or p-symmetry, asks if an object's spatial configuration can be changed in the mirror world, and if the physics of it would still work the same. For example, I could raise my left hand in real life, and my right hand gets raised in the mirror world. However, would the physics of that arm still work the same? Of course, it's just my hand. Time, or t-symmetry, essentially states that as long as physics is working properly, then I should be able to undo any mistake because it'll reflect on the time axis. Now, let's say I drop this glass. Whoops, well, that's okay because I can stop time and bring the glass right back into my hands if I needed to. Now what if I told you that all these symmetries can be broken? For the longest time, we thought nature was a stickler for symmetry.
But in 1956, Wu and her team discovered that parity isn't always conserved. They found that the beta decay of a particle prefers a direction despite the constant spin of the atom on both sides of the mirror, breaking the mirror's symmetry.
It's like finding out that your reflection can do things that you can't. Then came CP symmetry, combining charge and parity.
We thought it was invincible until 1964 when Cronin and Fitch saw neutral kaons violating this due to the way they decayed in two different forms unpredictably. Luckily, we still have CPT symmetry. It combines charge, parity, and time. If you flip all three, our universe should look and behave the same.
So here's to holding together or breaking CPT symmetry and achieving more breakthroughs in physics.